If you see the carbon negatively charged next to the phosphorus positively charged, that's the phosphorus yielded. Once you see that, you should think this is a Wittig reaction. It's going to make the double bonds. But how that goes? This nucleophilic carbon attack the electrophilic carbon of the carbonyl. Then you're going to make this O minus like Breeder's makes an attack. This is CH2, this CH2, that's the one that makes an attack. This one down here. Then these oxygen and phosphorus, they just click. They really love each other. There are several elements, a lot of things love oxygen, but the phosphorus is one of them. The most strongest bond you can ever think about is the oxygen-phosphorus bond. They're really making a strong bond. But once they make a bond, this makes a very constrained form and remaining, not happy. They want to break it up, not breaking the oxygen and the phosphorus bond. They rather want to break the carbon and oxygen or carbon and phosphorus bond. That's how you get double bonds. So you get double bonds formed, and you can make that. And if you think about it, that's diene. I can use that for the deals of the reaction. A lot of things combined now. This is a very simple reaction. But if you, can you see this is a Wittig reaction or not? That's kind of another thing. You're starting from the halide, so there's nothing look like this for the Wittig reaction because it's not shown yet. You gotta follow step by step. Now that's a kind of another thing you gotta get used to it. You should be able to follow step by step and carrying the reactions out so you can get to the end of the reactions. The first step is a triphenyl phosphate, which is a nucleophile that attack this carbon of and then kicking the bromines out. There's nothing but SN2 reactions. Once that happens, you're going to get the phosphorus positively charged. So this proton on the next position can be acidic, easily removed by strong base butyl that pick up these protons. Then you got the anion next to the cation. That's a phosphorus yielding. So that's what we see before. But it can be created by those two steps. I was able to recognize them. When they stay the ketone aldehyde, obviously this will attack that carbon and then we're going to make a double bonds. This make the carbon and then goes up. And of course, oxygen and phosphorus go away. So you don't have to go through that. You can easily combine these two to get the double bonds and then that will be no problems.